Now we'll talk about some characteristics of the solution of the differential equation. So how to find, for example, omega 0. This is our first part. So the question is, determine the angular frequency omega 0, but determine this angular frequency from the differential equation. So if it's from the differential equation, then simply we have x double prime plus k over m x is equal to 0. This is of the form, so it's of the form x double prime plus omega 0 square x equals to 0. And by identification, we'll get that this is k over m, this is omega 0 square, that omega 0 square is equals to k over m, which means that omega 0 equal to radical k over m. We use this one when the question is to find the angular frequency, but before giving us the solution. Now, what if the question is to find omega 0, and we have that x equal xm sine omega 0 t plus phi is a solution. In this case, we will have x double prime plus k over m x equals to 0, and x is solution. When it's solution, this means x verifies the differential equation, which means I must do the derivative and then substitute. So if x prime is equals to xm omega 0 cosine omega 0 t plus phi, and x double prime will be equal minus xm omega 0 squared sine omega 0 t plus phi, and we substitute. So by substitution, we'll get minus xm omega 0 squared sine omega 0 t plus phi, and plus k over m, then we put x, which is xm sine omega 0 t plus phi, and it's equals to 0. So here, if we identify or if we take, for example, this is, if we notice here, what do we have? Xm sine omega 0 t, these are common, so xm sine omega 0 t plus phi. We still have k over m minus omega 0 square is equal to 0, which means here that omega 0 square is equal to k over m. This means omega 0 equal radical k over m. So we'll get the same answer, but here if they ask us to, if the question was to find omega 0, knowing that we have the solution.